Hello everyone, this is Sir Rick and I would like to welcome you all to another video tutorial in our Math 10 class. Before we start class, I would like to ask a question and you have to give me the correct answer within 5 seconds. My question is, what is the sum of the first 100 counting numbers? The correct answer is 5050. Were you able to get the correct answer? How do we get the sum very quickly? We will find out later, class. In my last video tutorial, we talked about arithmetic sequence, and today in this video, we will talk about something related to arithmetic sequence, and that is arithmetic series. What is arithmetic series? Class, I would like you to remember that an expression denoting the sum of the terms of an arithmetic sequence is called arithmetic series. For example, in the arithmetic sequence 9, 4, -1, -6, and -11, its corresponding arithmetic series is 9 plus 4 plus -1 plus -6 plus -11. Knowing what arithmetic series is, we are now ready to solve some problems, class. Let us try the first one. Find the sum of the arithmetic series 1 plus 4 plus 7 plus 10 plus 13 plus 16. The addends, class, can be rewritten in such a way that the first and last terms are grouped together, the second and the second to the last terms are grouped, and the third and fourth terms also go together. If we add the group terms, we have 17 plus 17 plus 17, or is rewritten as 3 times 17, which gives us the sum of 51. It is interesting to note, class, that 17 is the sum of the first term and the sixth term, 1 and 16 in this case, and 3 is simply half the number of terms, which is 6 in this case. This idea, class, is going to be used in the next example. Find the sum of the terms of the arithmetic sequence 8, 12, 16, 20, 24, 28, 32, and 36. Using the same observation made, this example becomes 8 plus 12 plus 16 plus 20 plus 24 plus 28 plus 32 plus 36. The sequence has 8 terms, so we have to get 1/2 of 8, which is equal to 4. The sum of the first and last terms is 44, and it has to be multiplied to 4. Therefore, the sum of the terms of the given arithmetic sequence is 176. Let's move on to our third example. Find the sum of the terms of the arithmetic sequence -9, -4, 1, 6, 11, 16, 21, 26, 31, and 36. Using the same observation made, this example becomes -9 plus -4 plus 1 plus 6 plus 11 plus 16 plus 21 plus 26 plus 31 plus 36. The sequence has 10 terms, so we have to get 1/2 of 10, which is equal to 5. The sum of the first and last terms is 27, and it has to be multiplied to 5. Therefore, the sum of the terms of the given arithmetic sequence is 135. From the 3 given examples, class, we can now say that the sum of the first n terms of an arithmetic series, which we denote as S sub n, is S sub n equals n over 2 times a sub 1 plus a sub n, where n is the number of terms, a sub 1 is the first term, and a sub n is the last term. The first formula class will lead us to another formula in getting the sum of the terms of an arithmetic sequence. Recall that a sub n is equal to a sub 1 plus n minus 1 times d. Replacing a sub n in our first formula gives us S sub n is equal to n over 2 times a sub 1 plus a sub 1 plus n minus 1 times d. Or simplifying it gives us S sub n is equal to n over 2 times twice a sub 1 plus n minus 1 times d, where n is the number of terms, a sub 1 is the first term, and d is the common difference. Obviously, class, the first formula is used when the first term, the nth term, and the number of terms are known. The second formula is used when the first term, the number of terms, and the common difference are known. Let us go back to the first question I raised earlier, class. What is the sum of the first 100 counting numbers? Using the same observation or using the formula, this example becomes 1 plus 2 plus 3 plus 4 plus until plus 97 plus 98 plus 99 plus 100. The sequence has 100 terms, so we have to get 1 half of 100, which is equal to 50. The sum of the first and last terms is 101, and it has to be multiplied to 50. Therefore, the sum of the first 100 counting numbers is equal to 5050. Let us try our fifth example. A clock chimes every hour. The clock chimes once at 1 o'clock, twice at 2 o'clock, and so on. How many times will the clock chime from 1 p.m. through midnight? How many times will the clock chime in one 24-hour period? From 1 p.m., 2 p.m., 3 p.m. through 12 midnight, the clock will chime once, twice, thrice, and so on until 12 times respectively. Since we are looking for the number of times it will chime from 1 p.m. through 12 midnight, we are going to use the arithmetic series formula. Since we know that n is equal to 12, a sub 1 is equal to 1, and a sub 12 is equal to 12, we plug this in the formula. Hence, we have s sub 12 is equal to 12 over 2 times 1 plus 12. Simplifying this, we have s sub 12 is equal to 6 times 13, and multiplying 6 and 13 will give us 78. Therefore, the clock chimes 78 times from 1 p.m. until 12 midnight. To solve for the second question, we also know that from 1 a.m. through 12 noon, the clock chimes 78 times. So what we do is we just get twice the number of times the clock chimes from 1 p.m. through 12 midnight. Therefore, we have 78 times 2, which is equal to 156. The clock therefore chimes 156 times in one 24-hour period. Let us all together solve problem number 6. The number of seats in the first 14 rows of the center orchestra aisle in Aliw Theater in Pasay City form an arithmetic sequence. The first row has 11 seats, 12 in the second row, and so on. How many seats are in the 14th row? How many seats in total are in the first 14 rows? To solve the first question, we are going to determine the number of seats in the 14th row. This is obtained by using the formula for the nth term of an arithmetic sequence. That is, a sub n is equal to a sub 1 plus n minus 1 times d. Since my first term is 11, n is equal to 14, and the common difference is 1, we therefore have a sub 14 is equal to 11 plus 14 minus 1 times 1. Simplifying this, we have a sub 14 is equal to 11 plus 13, or a sub 14 is equal to 24. The second question asks us to determine the total seats in the first 14 rows. This is the same as adding 11 plus 12 plus 13 plus 14 and so forth until 24, which is the 14th term. Since I know the number of terms, the first term and the last term, we will solve the problem using the formula S sub n is equal to n over 2 times a sub 1 plus a sub n. Changing n with 14, a sub 1 with 11, and a sub n with 24, we have S sub 14 is equal to 14 over 2 times 11 plus 24. Simplifying it, we have S sub 14 is equal to 7 times 35, or S sub 14 is equal to 245. Let us try our seventh example. The first term of an arithmetic sequence is 1. If the sum of its first 9 terms is 3 times as large as the sum of the first 5 terms, what is the common difference of this arithmetic sequence? The first statement tells us that the first term a sub 1 is 1. The second statement also tells us that the sum of the first 9 terms denoted as S sub 9 is equal to thrice the sum of the first 5 terms denoted as S sub 5. And we are looking for the common difference. In math, the second statement is translated as S sub 9 is equal to 3S sub 5. We are going to kick off from this equation. Since we are looking for the common difference, we are going to make use of the second formula for arithmetic series, which is the one that I am flashing on the screen. From S sub 9 is equal to 3S sub 5, we now say that S sub 9 in the left part is 9 over 2 times 2 plus 8D. And 3S sub 5 on the right becomes 3 times 5 over 2 times 2 plus 4D. 2 and 2 in the denominator will cancel out, and 3 and 9 in the numerator are both divisible by 3. Hence, it will be reduced to 3 times 2 plus 8D, and that's equal to 5 times 2 plus 4D. Applying the distributive property, we have 6 plus 24D is equal to 10 plus 2D. Solving for D, we have 4D equals 4, or D is equal to 1. Therefore, the common difference of the arithmetic sequence is 1. Let us try our last example. The sum of the first 3 terms of an arithmetic sequence is negative 3, while the sum of the first 5 terms of the same sequence is 10. Find the common difference. From the given, we know that the sum of the first 3 terms is negative 3, the sum of the first 5 terms is 10, and that we are looking for the common difference. In this problem, we are going to use the second formula for arithmetic series. From the formula, I can generate an equation for S sub 3. That is, negative 3 is equal to 3 over 2 times 2a sub 1 plus 3 minus 1 times d. Cross multiplying 2 to negative 3, we have negative 6 is equal to 3 times 2a sub 1 plus 2d. Dividing both sides by 3 will give us negative 2 is equal to 2a sub 1 plus 2d, and dividing all the terms by 2 will give us negative 1 is equal to a sub 1 plus d. This equation has two unknowns. Therefore, we have to set up another equation to solve for d. Using the second equation of arithmetic series to generate another equation for S sub 5, we have 10 is equal to 5 over 2 times 2a sub 1 plus 5 minus 1 times d. Cross multiplying 2 to 10 will give us 20 is equal to 5 times 2a sub 1 plus 4d. Dividing both sides by 5 will reduce the equation to 4 is equal to 2a sub 1 plus 4d. Dividing all the terms by 2 will further simplify the equation to 2 equals a sub 1 plus 2d. We let this be the second equation. Subtracting now equation 1 from equation 2, we get 3 as the value of the common difference. Before I end, I would like to acknowledge all the sources of the problems I placed in this video. So that ends our video tutorial class. I hope you learned something today. Watch out for my next videos. Be healthy, be safe. Until then,